Good afternoon, guys. So we have seen in previous class so in the previous class we have seen about genetic algorithms. Okay. So here, if you see in genetic algorithms, it is one of the biological evaluation, okay, which is motivated by biological evaluation. And genetic algorithms search the hypothesis space by generating its successive hypothesis, okay, which repeatedly uses mutation and recombine the parts of the best currently known hypothesis. So this is the flowchart. In genetic algorithm, it consists of three operators. First is select operator, second one is crossover, third one is mutation. By use of these three, we will be getting the best result. Okay. So the select operator is used to select the parents for mating. Crossover is used to find the fitness, that is the probability of a particular instance in the data set. Mutation is used to mutate the string to get the new string here. Okay.
Excuse me, ma'am.
Yes.
Are you sharing the screen?
No. Just I'm repeating the topic.
Okay, ma'am.
Now can you see the screen?
Yes, ma'am.
Okay. So again, genetic algorithm, in particular algorithm, we will be using these three operators. By the use of these three operators only, you will be finding the best result. Okay, best solution. So here, how you are going to represent the hypothesis? So here in genetic algorithm, hypotheses are often represented with the help of by bit strings, that is ones and zeros. Okay, so that they can be easily manipulated by genetic operators. So what are the operators? Selection, crossover, and mutation. So when we use these operators, we will be representing the string in the form of ones and zeros only. Then only we can find the output. Okay. So here one example: outlook is equal to overcast. Outlook is equal to overcast. So outlook is equal to overcast. And rain or rain, okay, and wind is equal to storm, so that can be represented in this form. So that particular rule can be represented in this form. In the same way, if wind is equal to storm, then play tennis is equal to yes. Okay, so that can be represented in this form. So system will be converting the data into bit strings when we use genetic algorithm. Okay. So you will be having three different types of crossover techniques. One is single point. That is nothing but from one point we will cross over the strings from one string to another string. Okay, that is to form new offspring. Second technique is 2-point crossover. That is nothing but I'll show you the examples also. So this is the example. So here you can see single point crossover. That is nothing but we are using only single point to combine these two strings. Okay, 2-point crossover is nothing but we are using 2 points in a particular string. Okay, and the uniform crossover is nothing but multiple points. So here one, here one, here one, here one. So this is combined with the other values in the second string. Okay, so that is uniform string. So these are the different techniques which are used in the crossover. The last one is mutation. In mutation we will be using point mutation. Okay, so here is one example. Point mutation is nothing but this is the string. If you want to mutate any particular value, so if you want to mutate this particular value 0, so that will be converted into 1. That is represented as 1, and then we can use that string for processing. Okay, if we are having 1, this will be converted to 0. Okay, so whatever the strings which we take, that will be selected randomly. So next is hypothesis-based search. Okay, so what is hypothesis-based search? Hypothesis-based search is nothing but we will be having come after 1 hour. So here in hypothesis space, what is hypothesis space? It is a collection of group of different hypotheses and the different types of outputs. Okay. So here hypothesis space is nothing but genetic algorithm search can move very abruptly as compared to backpropagation. For example, replacing a parent hypothesis by an offspring that may be radically different from the parent. That is nothing but if we are using any string. So this string is main string which we are using. So what we are doing here, this can be converted by using crossover technique. Then we will get one new offspring. అంటే ఇది పేరెంట్ స్ట్రింగ్ అయితే ఇక్కడ వచ్చేది మనకి న్యూ స్ట్రింగ్, దీన్ని మనం ఆఫ్ స్ట్రింగ్ అంటాం. ఓకే, replacing a parent hypothesis by an offspring that may be radically different from the parent. Obviously, when we convert it into offspring, the parent string will be different. Okay. So while doing, there will be a problem called as crowding. Okay. So what is crowding? When one individual is more fit than others, this individual and the closely related ones will take up a large fraction of the population. So if we are considering a particular value, okay, we should not consider only one particular value. We have to consider many values to get the output. ఒకదాన్ని తీసుకొని మనకి బెస్ట్ అవుట్పుట్ రావాలంటే కాదు. ఓకే, కానీ మనం ఇక్కడ గ్రూప్ ఆఫ్ వేరియబుల్స్ తీసుకొని కన్వర్ట్ చేయాలి, అప్లై చేయాలి జెనెటిక్ అల్గోరిథం. ఓకే, సింగిల్ వాల్యూ తీసుకున్నప్పుడు అది ఫిట్ కాదు. More values తీసుకున్నప్పుడే different random variables with more values, it will be best, we will get best result. Okay, so that is nothing but crowding. అంటే ఒకదాని తర్వాత ఒకటి, ఒకదాని తర్వాత ఒకటి, ఒకదాని తర్వాత ఒకటి. సో ఇక్కడ మనం కంటిన్యూస్గా తీసుకుంటే అంటే క్రౌడ్ ఎక్కువ అయిపోయి సిస్టమ్ it will we will have some problem at some place. Okay. So to overcome that, we will be using different types of techniques like roulating, pain selection, tournament selections, rank selection. These are different types of selections used as a crowd ni overcome cheyadaniki. Okay, so ర్యాంక్ సెలెక్షన్ అంటే ఏంటి అని అంటే ఎగ్జాంపుల్ ఒక స్కూల్లో దే ఆర్ కండక్టింగ్ సమ్ అథ్లెటిక్స్ ఓకే రన్నింగ్. సో దాంట్లో కొంతమంది పార్టిసిపేట్ చేస్తారు. పార్టిసిపేట్ చేసేటప్పుడు అందరికీ ర్యాంక్ రాదు, కొంతమందికి మాత్రమే ర్యాంక్ వస్తుంది. ఓకే, సో అకార్డింగ్ టు దేర్ స్టామినా ఒకరు ఫస్ట్ వస్తారు, ఒకరు సెకండ్ వస్తారు, ఒకరు థర్డ్ వస్తారు. సో ఇట్లా ఒక్కొక్క దానికి మనం ర్యాంక్ సిస్టమ్ ఇస్తాం. ఫస్ట్ వచ్చే వాళ్ళకి ఫస్ట్, సెకండ్ వచ్చే వాళ్ళకి సెకండ్, థర్డ్ వచ్చే వాళ్ళకి థర్డ్, అట్లా మనం ర్యాంకింగ్ సిస్టమ్ ప్రొవైడ్ చేస్తాం. ఇన్ ద సేమ్ వే in rank, by using rank selection also, whatever the instances or records which are there in the data set, all will not have equal probability. Okay, so they will have different probability. So according to the data we will run them. For that purpose we will be using rank selection technique. So this I have told you. Next is genetic programming. Genetic programming అంటే ఏంటంటే you'll be having different types of parameters. Those are called as programming control law. So what will happen here means it is just like nested tree. Okay, so this tree can provide different solution by using different types of genetic algorithms or genetic programming. ఏదైతే మన దగ్గర డేటా ఉంటుందో దాన్ని మనం ఏం చేస్తున్నాం, ప్రోగ్రామింగ్ కన్వర్ట్ చేసి దాన్ని మనం అప్లై చేస్తున్నాం. So here you can see, so this is one type of program. So this is converted into a tree. Okay, so this is applied to one particular algorithm to get the output. So for that purpose we will be using genetic programming. Genetic programming అంటే ఏంటంటే ఏదైతే డేటా ఉంటుందో దాన్ని ప్రోగ్రామింగ్ కి కన్వర్ట్ చేసి దాన్ని ట్రీ స్ట్రక్చర్ లైక్ ఫామ్ తెచ్చుకొని దానికి మనం algorithm కి అప్లై చేస్తాం. ఓకే, సో దట్ ఈస్ నథింగ్ బట్ genetic programming. So that's all about genetic programming. So next is learning set of rules. So what is learning set of rules? Actually, it is a method of mathematical logic or mathematical algorithm which improves the network performance on different training time. Okay, so what it is a method of mathematical logic or mathematical algorithm which is used to improve the network performance on training time. Okay, so for this we will be using set of rules. If the same example ఏంటంటే we are insisting you to come to the college. Okay, so how we are insisting you with regular no, we are insisting you to write the we will be allowing you to write the exam if you follow some rules. Okay, so what are the rules? You have to maintain the attendance, 75% attendance. Okay, next you have to follow all the rules, you have to attend all the classes. Okay, you have to write the records if it is lab subject. So likewise, so what we are doing here, we are framing some set of rules. Okay, so that is learning set of rules. So the system will learn different set of rules. It will form different set of rules here. Okay, So when we need a set of rules, so in machine learning system, it is a rule-based system that you know. Okay. Okay. So here in machine learning system, it is a rule-based system. So it helps in identification and utilizing of set of relational rules that collectively represent the knowledge captured by the system, which is captured by the system. What it will do, it will identify something, and that will be utilized with the set of rules, relations will be given to the data. Okay, and this particular knowledge will be captured by the system. Okay, so now what is happening here? Now this learning rules, if we utilize it, instead of taking a decision tree, lengthy decision tree, and given the rules to the code in the form of rule, then it will be proper utilization. So then we will get set of rules here. Okay. So this, what will happen with this? This reduces the time and improves the performance. So this is called as learning rule. Okay. So here in genetic algorithms, one way of representing hypothesis is if then else. So in the previous class I have told you how you are going to do that is nothing but in genetic program. So you will be representing the data in the form of if then rules, and that will be converted to tree, and that with that we will be applying some algorithm to get the output. Okay. So it is very expressive representation of hypothesis and easy understandable representation that we use if then else structure to our data. Okay, and in decision tree also we have used if then else. So there what we have done, we have created decision tree and we have translated it into set of if then rules. Decision tree generate JC, we have converted it into if then else. Okay, with that we have got the solution. So in genetic algorithm also we have used if then else. Okay, so here in classification technique we are having two types. Okay, so first type of classification, again it is divided into two. So what are these two? So there we will be using two things. One is decision rule, another one is genetic algorithm. Okay, so you can see here. Method 1, learn decision tree, translate tree into rules. So this is decision tree. So what we are doing in classification, we are using two types. First type of classification we are using two types. One is decision tree, another one is genetic algorithm. Okay. So if you see decision tree, what we are doing, consider decision tree. Machine understands and learns the decision tree, then it translates the decision tree into a set of rules. That is in case of decision tree. And in case of this second technique, under first type of classification, second technique is genetic algorithms. So what will happen in genetic algorithms? The rule is represented in the form of bit strings. Okay, in the form of, that is in the form of ones and zeros. Why? Because the system will not understand. So it is converted into ones and zeros. and it uses genetic search operator. So what are the search operators here? That is the select operator, crossover operator, mutation operator, so likewise. So genetic algorithm uses search operator to explore the hypothesis space. So what is hypothesis space here? Okay, so this is first type of classification. First type of classification we are having two types. One is decision tree, and another one is genetic algorithm. In decision tree, first we consider the decision tree, and machine will understand the decision tree, and then it translates the decision tree into set of rules. This is the first type. Second one is genetic algorithm. In genetic algorithm, the rule is represented in the form of these bit strings, and we will apply the genetic search operator to explore the hypothesis space. Okay. Now, the second type of classification is first order rules. Okay. So, what is first order rules? First order rule is nothing but it is also called as formed class. So, second type of classification is first order rules. Okay, so this is also called as formed class. So what it is? So here it consists of different variables. Okay, so if you take x and y, what are the variables here? Suppose if you take x, y. Okay. So here x and y considered as variable value, okay, considered as different variables without knowing the variable value. So we don't know the variable value here. Okay. Now what we are going to generate the rules by these variables. Okay. So the mainly used technique here in learning set of rules is first order rule. So listen carefully. First order rule is nothing but here it consists of different variables x, y, z, so like this. So different variables will be there. Okay. Now, without knowing the variable value, so what is the x value we don't know, what is the y value we don't know. Without knowing the variable value, we are going to define the rules here. So without knowing the value, we are going to generate the rules. So that is in case of first order rule. So this is one of the technique which is used under classification. So this is called as learning set of rules. That is learning set of rules. In learning set of rules, we will be using first order rule. Okay. So what is first order rule? First order rule is nothing but it is one of the classification technique. The first order rule is nothing but you will be using different types of variables. Okay, and to that variables we don't know what is the value. So without knowing the value of that particular variable, we will be generating different types of rules. Okay. So it is called as first order rule or formed class. So I'll give you one example. If parent of x comma y, then of x comma y. Okay, so just see here, I am applying first order rule here. So what is happening here? I am having the data. I am having different types of variables. So what are the variables? X comma y are the variables. I don't know what is the value for that. Now what I am doing? I am generating the rules here. So how I am generating here? If parent of x comma y, then ancestor of x comma y. So what it is? Parent of x comma y ante y is parent of x. Then ancestor of x comma y ante y is chosen as ancestor of x. Okay, so this is the output. So for that we are generating this particular rule. In the same way, one more rule. If x comma z and system of z comma y, then system of x comma y. Okay. So what is the meaning of this particular rule? Z is father of x. Z is father of mother and father and. Okay. So Z is either father or mother of x. And this is and y is ancestor of z. Y is ancestor of z. Then y is ancestor of x also. X also. So this is the meaning. But here z is so here, have you understood? Z is parent of x. Then y is ancestor of x. Okay. So in this way, we will be framing the rules here. So we will be generating different types of rules. So these are called as first order rules. Okay, so for this, for generating these particular rules, what we want different types of algorithms. Okay, so that particular algorithm we will be using here is sequential covering algorithm. Okay, so what we are doing, we learn first order rules that contain different variables. Okay. And we need some algorithms included that to help to frame the rules. Okay, to learn the rules. Okay, so at a time we can learn one rule, which will be developed by sequential covering algorithm. So with the help of sequential covering algorithm, we can generate different types of rules here. Okay, so this is the algorithm which we will be using here. So what is this algorithm? Okay, so here one more thing. Learning the first order horn class or learning first order rule is also called as inductive logic programming. Okay, so it is also called as inductive logic programming. So what is sequential covering algorithm? So sequentially cover each rule which are in data set. Data set లో ఉన్న డేటాను అంతా కవర్ చేస్తారు. అన్నిటికీ రూల్స్ ఫ్రేమ్ చేస్తారు. అన్ని ఇన్స్టాన్సెస్కి అన్ని డేటాకి రూల్స్ ఫ్రేమ్ చేస్తారు. ఓకే, it extracts different rules from data set directly. Okay, and whatever the rules which we will grow, that will be in the form of greedy way. Okay, and here it will have evaluation measure. So what is evaluation measure? Evaluation measure is nothing but either accuracy or coverage of all the data. So what is the accuracy? Accuracy is nothing but what is the confidence factor. Okay, and here one rule which is generated at a time for records belonging to two classes. We will be generating one rule by using two classes. Okay, so here which class to be generated first depends upon the certain factors or the cost of misclassification in the records. What is that particular factor? One factor is nothing but class prevalence. We call it as class prevalence. What is class prevalence? Class prevalence is nothing but it is a fraction of training records belonging to that particular class. Okay, so we will see what is that particular algorithm is. So sequential covering. So here main thing to consider here is that learn one rule at a time and it accepts positive and negative training examples as input. Okay, positive and negative ante yes or no, 1 or 0 or true or false. So all these target concept values అనేవి అంటే ఏదైతే డేటా సెట్ లో ఉన్న different records ఉన్నాయో అవి కన్సిడర్ చేస్తుంది అని. Okay, so those are considered as input. Okay, and for getting the output for generating the rule, many positive training examples and only few negative examples will be considered. Okay, so see here input. What we are taking as input? Target attribute. Target attribute అంటే example. So this is the data set which you are having here. So this is the data set. Name A, B, C, D. Okay. Roll numbers 1, 2, 3, 4. Marks some 20, 30, fail, Okay, 50, 70, pass. So likewise. Okay. So what is target concept? Target concept is this. Target attribute at this. What is the target attribute? For this particular instance, it is false. For this particular instance, it is pass. Okay. So now in sequential covering algorithm, you are taking the input as target attribute. What are the different attributes which are having? Attributes ఏంటి? ఇక్కడ మన డేటా సెట్ లో ఏంటి attributes? ఇది name. Okay, this is or ticket number. These are marks 1. This marks 2. This is result. So వీటిని మనం attributes. So these attributes which are considered here. Okay. So we will consider target attribute, different attributes, and examples. Examples are say, okay, and we will consider one threshold also. One threshold also. Okay. So here as input we provide target attribute. To learn the target value, all the training examples attributes are considered, and we will consider one threshold value. Okay, so this is as input. Now, learned rules. So initially there will be no rules. So what we are doing here, we are taking the rule as empty. Okay. Next step is the rule. So we have to generate the rule here. That is learn one rule. So for generating the rule, what we are doing, target attribute, different attributes, and examples. So we need to generate a rule, we need all these things. Okay. So here function which training example one by one it learns different rules. So what we are doing here, we are calling a function here. Okay. So here we are calling a function. So that function which training example one by one it has to generate the rule or it has to learn the rule. It will tell us, that function will tell us. Okay. So here without example, attributes and target value, we learn one rule. Next is while performance. While performance, rule examples greater than threshold do. Learned rules, examples, and rule. So if performance of that particular rule is greater than threshold, okay, if performance of that particular rule is greater than threshold, now set one value. Okay, so now set one value. If performance is greater, this value, that means fitness is high, the rule which we learn, or we have hypothesis there. So what we are doing, we are generating some hypothesis. If performance is greater than threshold, generate one rule. Okay, so learn one rule with that particular input data. So here one rule will be generated. That is nothing but one hypothesis is generated. Okay, next, learned rules. So whatever the rules which are generated, those are generated as the output here. So those are nothing but learned rules. Now what you have to do, you have to sort all the rules according to the performance. So this is the algorithm. So first what we are doing, take the input data as target attribute. What are the attributes which we are having as examples, and consider one threshold. Okay, threshold you can consider it as 10, 20, 30, 40, so like this. Okay, so if target value or attribute is greater than that particular threshold, so what we have to do, generate one rule. If it is less than threshold, then come out of the loop. So that is something that we are generating if then else. If then else loop is generated here. Okay. So that is in case of sequential cover algorithm. For generating the rules, we will be using sequential covering algorithm. So I show you one example that you can know. So again I'll repeat it. First it creates empty set of decision list. One function is called as learn one rule. Okay. What it will do, it classify all the positive examples for that particular instance, and it extracts the best rule. Okay. If all the training examples belongs to that particular rule, that particular class, we will specify it as positive. Okay, so here we are generating the rule here. If all the training examples does not belong to that particular class, that are classified as negative. Okay, so when you call a particular rule which are desirable, it is called as desirable only. When it covers all the positive examples, అన్ని పాజిటివ్ ఎగ్జాంపుల్స్ని కవర్ చేసి మనకి రూల్స్ని జనరేట్ చేస్తే దాన్ని మనం డిజైర్డ్ అవుట్పుట్ అంటాము, డిజైర్డ్ రూల్స్ అంటాము. ఓకే, సో ఫర్ దిస్ వాట్ we are doing here, find the search rule. We are going to search the rule here. Then eliminate all the training records associated with that particular rule. Rule generate చేసినాక ఏవైతే రూల్ని మనం జనరేట్ చేస్తున్నామో, ఏవైతే ఎగ్జాంపుల్స్ని జనరేట్ ఏదైనా ఎగ్జాంపుల్స్ జనరేట్ చేస్తున్నామో ఆ ఎగ్జాంపుల్స్ అన్నింటినీ రిమూవ్ చేయండి. ఓకే, now new rule is added here. So in the same way, in this way we will be generating different types of rules here. Okay. So you can see on the screen, this is the data set which we are having with positive value and negative value. Okay, now what is happening, we are applying the sequential covering algorithm. Okay, just a moment, I'll close within 1 or 2 minutes, don't worry. So see here on the left hand side, this is the total data set which we are having. Okay, positive values and negative values. Okay, so how many positive values we are having? In the topmost, we are having 6. So here we are having 4. Here we are having 5. Okay, so what will happen? We will apply sequential covering algorithm. So what it will do? It will find the highest positive values in the data set. So highest positive values are these. So what will happen? With this particular data, rule 1 is generated. Okay, again the process is repeated, then it selects for the highest positive values. So here this is highest positive value. Okay, now this is generated as rule 2 and this is generated as rule 3. Okay, so in this way, while applying the sequential covering algorithm, it will to generate the rules, it will check the highest positive value. If the highest positive value is classified, higher group is selected. So that is represented with rule 1. So to that rule 1 is generated. Next highest group of positive values will be generated with rule 2. Next positive values is generated with rule 3. So likewise. So in this way we will be generating the rules for our data set. So okay guys, Sagar, can you share me the attendance please? Just send a message, done. You can leave.